So in brief, we'll study about for the case 1. Case 1 is what? The overdamped. Okay, for the overdamped, case 1 is overdamped. In this case, step number 1, how do we know that it is overdamped? First of all, we need to calculate the value of alpha s. I'm telling you for the series. Okay, for parallel it is different one. Alpha s and omega s. For alpha s, it is for alpha is for the damping factor. Alpha is what? The damping factor. Okay, and it is in series, that's why I denoted by s. Its formula is r by 2l. For parallel, formula is different. And what is omega s? Omega s is the angular frequency. Okay, for omega s, formula is 1 by root over LC. Its unit is Nepper per second. Okay, and its unit is radian per second. Clear? Now how do we know that this is the case of overdamped? If alpha value is greater than omega naught, then that would be the case of overdamped. Okay, so that was step number 1 completed. Then in the step number 2, we have to calculate the equation, that is s square plus 2 alpha s plus omega naught square. From this equation, can we get the value of s1 and s2? Right? Remember the formula like minus b plus minus root of alpha square minus b. So this formula will apply. That would be minus alpha plus root of alpha square minus omega square. Again minus alpha square minus omega square. Okay. So what is this s1 and s2? S1 and s2 are the natural frequencies. We all are studying for this natural response. Remember I told you there are two types of response. One is forced response, one is natural. So this is all for the natural response. Okay. Step number 2 is also done. Step number 1, calculate alpha and omega. Step number 2, calculate s1 and s2. Now the step number 3, we have to calculate the equation for the overdamped. Particular, this is for the overdamped. Okay, for OD, that is I2 is equal to a1 e raised to power s1t plus a2 e raised to power s2t, right? So for this we should know the value of s1 we already calculated, s2 also we already calculated, right? IT maybe they have given in the question, or maybe we need to calculate. Okay, clear? IT means I of 0. So now we need to calculate the value of a1 and a2, right? For the calculation of a1 and a2, we have to follow step number 4. For step number 4, we have to do at t equal to 0. Okay, for time t equal to 0, we can put t here 0, so that would be I of 0, that would be a1. E raised to power 0 is 1, right? Again a2, t will put 0, e raised to power 0 is again 1, so that would be a1 plus a2, so that is I of 0. I of 0 maybe they'll directly mention in the question, or maybe you need to calculate for at t equal to 0 minus. Okay, clear? Step number 1, 4 clear. Now from this we'll get one single equation for the calculation of a1 and a2. We need one more equation now to solve it. For this we have to follow step number 5. Step number 5 is differentiate the existing equation. Like our equation is it a1 e raised to power s1t plus e s2t, right? We have to differentiate di by dt, right? If we'll differentiate it, a1 will remain as it is, s1 will come in front, e raised to power s1t, right? a2 will remain as it is, s2 e raised to power s2t. Now again we have to do it for at t equal to 0, right? So that would be di of dt at 0. If we'll put t equal to 0, then it would be a1 s1, because e raised to power 0 is only 1, right? Clear? So a1 s1 plus a2 s2. So again, we already know the value of s1 and s2 that we have calculated in step number 2, and di by dt maybe they have mentioned, or maybe we need to calculate in the question. Okay, so now we'll get the two equation. One is this equation, right, from the step number 5. Another is this equation. So these two equation will help in solving the value of a1 and a2, right? After getting the value of a1 and a2, we can put it in the standard equation. Now we know the value of a1 also, s1 also, t will remain as it is, a2 also, s2 also, and again t will remain as it is. This is the case of over damped series case. Got it?